As a really bad face. I really don't go to Oh. No, I don't know. So I can't use that. I feel in regional responsibilities.
Proportion confidence interval question, guys. Okay, so the formula you're going to be using is not about means. Okay, this question is not about averages or means or populations. I stop talking, please. Okay, so this question is about proportion. Okay, and your proportion formula is where? Okay, if you look on your formula sheets, okay, you're going to end up using this formula over here. And we're going to find a confidence interval for that. Because this question doesn't mention means. Okay. So it's not our normal mean confidence interval question. It's using a confidence interval for proportion, right? Okay. So you're going to be using this formula here, where the confidence, what does P stand for? The population proportion, right? Okay, the confidence interval. So I want to be able to end up saying I'm 90, whatever it is, 98% confidence that it lies between this and this, right? So P is the population proportion. On your formula sheet, you should have changed this to P hat is equal to P hat plus minus Z. Z, remember, comes from the confidence interval. Okay. P hat 1 minus P hat over N. Okay, so be very careful you're using the right formula. Use the wrong formula, 0. Okay. It's fine. I'll let you this test I'm not worried about. I will raise the average to be fine. Okay.
Yeah, but what if we right at the bottom and then?
They are raising a lot. Right. Okay. Next 2 weeks, we're just going to be doing revision. So is this 15% P or P hat? That's P hat, right? From the survey. Okay. So P hat is equal to 15%, which is 0.15. Hang on, wait. No, that's not, that 15% is not P hat, guys. Okay. Listen to the question. Listen to the question. Council publishes the plan, right? 15% accepted the plan. Okay. And then went and revised the plan. Okay. And from the revised plan, okay, so we're working with this bit over here. Okay. Out of a sample of 360 accepted the plan. That's the part of the question I'm working with. Okay. This comes into the next question. That 15% bit. Okay. So what is P hat stand for? From a survey, what's the proportion? Right? So P hat, okay, the population that accepted the revised plan, okay, so P hat is equal to what? 60 out of 300, right? Which simplifies to what? Okay. What's N equal to? How many people were asked the survey? 300, right? Okay, so N is equal to 300. There you go. Look like you need a hat. Okay. Right. P hat is from the survey. So from somebody does a survey, right? and they work out the proportion of the people that have cars, or the proportion of people who've been to jail, or something like that, right? Okay, that is called P hat. That's from a survey. From the survey and the size of the survey, what do we go work out? We work a confidence interval for the actual proportion in whatever we're looking at. So the confidence interval for the number of people in the proportion that have cars in the country. So here I want a confidence interval for the whole whatever town. Okay. So I'm looking for a confidence interval for P, which is the population proportion. Okay. Okay. No, we don't. We've got a working out P. Okay. The 98, that is 4P. We want to be able to say 98% confidence that all the what proportion of local residents accepted the revised plan. That's why they've highlighted the word revised here, to show you it's working with the revised question. That 15% report was revised. You with? Okay. So what's going on here is this, guys. Remember, we draw a picture. In a population confidence interval, what's happening? Okay. For confidence intervals, what goes in the middle? Okay, remember, if it was to do with means, then the mean of your survey goes here, and we found a confidence interval for the lower boundary for mu. What did mu stand for? The population mean. Okay, and an upper boundary for the population mean, depending on what the confidence interval is. Okay, so we wanted to say I'm 98% confident, okay, that the population mean based on this X bar lies between such and such. X bar is always in the middle of your confidence interval. Likewise for proportion, okay, what goes in the middle is just like here was your survey mean. Here's my survey proportion. Okay, what's our objective? We want to find a lower boundary for P. What does P stand for? The population proportion, and an upper boundary for P, the population proportion, right? In this particular case, okay, they said the confidence interval must be what? 98%, right? So this area is 98%. This, by the way, is called the width of the confidence interval. Okay. Right. In order to do this, I need two things. Okay, first of all, how do I find the Z scores that go with that confidence interval? How do I find, so this is your P values. Okay, this is your Z scores that go with them. So that Z score is 0. Okay, how do I find this Z score? By using your confidence interval, right? Okay, so go find your upper Z score and your lower Z score for a 98% confidence interval. You're not going to put me the sheets. You need a formula. So this area is what? 98 divided by 2? 0.49, eh?
Yeah.
So we want to know H of Z is equal to 0.49. So Z is going to be, if you look up an area of 0.49, what did you get for your Z score? 2.33. Did you get that? What's going on in the diagram? Okay. This is 2,33 over here. And this is negative 2,33. Okay. So far, so good? Okay. So now I have to go and get the confidence interval using this formula over here. So I want to get, this is going to give me my upper and my lower boundary for P for a 98% confidence interval. Okay, so we're going to end up with, okay, if I use that formula, we're going to get P is equal to P hat. What was P hat? 0,2. Okay, plus minus, the Z score for a 98% confidence interval is 2,33. Okay, then I'm going to have okay. So I'm going to end up with P hat, which was 0,2, 1 minus P hat, which is going to be 0,8 over N, which was 300, right? That's going to give me a confidence is to 4 decimal digits, right? IEB. So P is an element of what and what? Rosemary, what did you get?
So, 0.162.
Good.
0.253.
But in the context of this question, okay, so first of all, is everyone okay with that? What's our first check with confidence intervals? Is it proportion, or is it talking about proportions? It was talking about means. Okay. Right. So what is this? What have we worked out? That between 14,62 and 25,38% of residents, okay, we can be 98% sure. How would you answer this in words? We can be 98% sure that between 14,62% and 25,38% of these local residents accepted the revised plan. Okay. What would happen if I made, what would happen to the if I made, I don't know, let's not just to stick to the question. Right. Okay. Any problems with that? Are we all good? Okay.
The next question.
Right. So the next question, well, first of all, look at the mark allocation. It's telling you there's not much work to be done. Okay. It says, using the confidence interval in 4.1a is evidence to support the claim that the proportion of local residents who accepted the revised plan is greater than the support for the original plan, right? Well, in the original, so what have we worked out our boundaries are now? What were our two boundaries, guys? My lower boundary was what? For my confidence interval, 0, in other words, 14. So the revised plan, we could say with between 98% confidence that between 14,62 and 25,38% of residents accepted the revised plan, right? Okay, so it falls in that region. That's 15% fall within that region. Here's 15%, okay, over here, right? 14,62, I'm going across on the x-axis. 15% lives here. Is it in the 98% confidence interval? Yes, it is. It's in the, okay, this is not hypothesis testing. Okay, so the revised survey said what? We're 98% sure that somewhere between what and what, except for the revised plan. Somewhere between 14,62 and 25,3%. Somewhere in that region, right? Accepted the revised plan. 98%. This, the original one was 15%. Is it? It's still in the 98% confidence interval. Okay. So there's no evidence to support that the revised plan is any bit better. If it had been out of here, if it had been like 30,2%, then it's outside of the confidence interval, there's a difference. Or sorry, other way around. If it was like over here, 10%, or if the confidence interval was between 30 and 60, okay, then 15,62 would be a problem. You with me? But it's lying within the 98% confidence interval of the revised plan, so there's no significant difference. The actual memo, by the way, says the following. So since 15% is in the interval, there is no evidence to suggest that the percentage of residents who have approved, that's terrible English, the revised plan. Forget about the way they wrote it. Does that make sense? Okay, the revised plan, that was a confidence interval. The original proportion is in the confidence interval, nothing's really changed. Okay. I don't want you to get stuck on this paper. Okay.
So is the answer yes or no?
No.
The answer is no. The revised plan is no better than the original plan. Okay. Because the original plan, 15% accepted. Okay. The revised plan is between 14, it's somewhere between 14.62 and 25. It hasn't really changed. You with me? Okay. In the original plan, 15% accepted the original plan. For the revised plan, between 14.62 and 25.38%, we estimate accepted the plan. 15% falls within an interval, so nothing's really changed. Okay, so there's no evidence to indicate that the revised plan is any better and more acceptance than the original plan. Okay, right, moving on. Okay, try the next one. Do you want me to do an online session? Like at about 6 tonight?
Yes, please.
Okay. I'll carry on working through up another past paper. Okay. I'm not going to do 2022. You don't have to go to the, you can rather work on your own, work on your own. I will not judge you if you're not there. Okay, but if you this stage, I think some of you are still figuring this all out, which is I understand. As I say, I'm not worried about tomorrow's test. Okay. That we will adjust the marks for if needed.
You know what I think we should do, sir?
No.
I think no. I actually think it's a good idea.
Yes.
I think that we should write this test and then to write the exam. You should be able to take the higher mark used.
Probably I'm only going to get the exam mark next year.
What? So we should write the test. Yeah. So can we?
Guys, hey, I told you, I want you to do your best for this test. I will adjust the marks. Okay, we're writing it. It's going to count. Do your best. Okay. Don't worry. Okay, you don't have to watch the video. Okay, right. Okay, so, yep. 4.2. Okay. Okay, right. So, guys, remember in these formulas, okay, your formula on your formula sheet. I'll live from 5:30 to 7 tonight. Okay. Okay, so the formula we're going to be using now is this one over here. Okay, Z is equal to X bar minus Y bar minus mu X minus mu Y over sigma X squared divided by the number in X plus sigma Y squared over the number in Y. Okay. What's my diagram going to be talking about when we draw a normal distribution diagram? Okay, we're going to have normally on the axes we just have X bar. Okay, now okay, what we're really looking at is X bar minus Y bar over here, and the Z scores that go with it. So we're trying to see if there's a significant difference. Right, so the question says, okay, in order to compare the performance Okay, so we've got blah, 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 blah. Test at the 2% level of significance whether the mean volume content for the first machine, okay, the first machine is X, okay, is greater than the mean volume of the second machine, right? So sometimes with these, it's easier to start with your with your counter hypothesis. Remember, you've got to always write down H0 and H1. Counter hypothesis. What's this guy trying to prove here, guys? Is it a one-tailed test or a two-tailed test, first of all? What does it say? Greater. If it's different, it's a two-tailed, right? So what they're proposing here, okay, is the counter hypothesis is that X bar is what? Greater than Y bar. In other words, that X bar minus Y bar is greater than 0, right? Does that make sense? That's what's trying to be proved in this by the significance test. What's the original assumption then? That they are equal, right? That X bar is equal to Y bar. In other words, and this is going to be important, that X bar minus Y bar equals 0. Why is that important? Okay, because if I look in the formula, that's going to just become 0. No, man, I'm speaking absolute cuck. I'm so sorry. Rub that all out. We're talking about the hypothesis about the overall population, right? Okay, head slap, any more mistakes? Okay, so that we're talking about the hypothesis. Why are we doing this survey? We want to know if overall in the whole population, is there a difference between the means? Okay, so what's population notation for the whole population mean? Is it mu or is it X bar? Mu, right? Can't do an hypothesis about the survey. We've got the survey, right? You with me? Sorry. So H1 is that mu of X is greater than mu of Y. In other words, that mu X minus mu Y, okay, is greater than 0. We're trying to find out about the whole population of West. Those are always going to be mu's. Okay, so what's the original belief? That mu X was equal to mu Y. In other words, that mu X minus mu Y is equal to 0. So we do a survey with X bar. Do you understand X bar and Y bar about the surveys? Whereas mu is the whole population. Okay. So we know that this mu is the population mean for the whole thing. So this is going to, in the formula, is going to be equal to 0, right? Okay, because mu X minus mu Y is equal to 0. Okay. Right, now, okay. It's a one-tailed test. Is it to the right or is it to the left? We look at X bars minus Y bars, right? It's to the, as I said, X bar is bigger than that, right? So at what significance level are we working with? 2%. So this is a one-tailed test, okay, and this area over here is 2%. Okay. So now, okay, what do we have to go figure out now? Whether this, for the samples, whether it falls into this area over here, right? To see if it falls into that area, I've got to find the Z-score that goes with the one-tailed test of 2%, right? Okay, go get the Z-score. So what's that called? My critical Z-score, right? Okay, so go get your critical Z-score for a one-tailed 2% test. It's stuff that you wanted to buy is not on the test tomorrow. Sorry. Yeah, that limb stuff is on the test tomorrow. That median and low. Okay. Right. So Z critical, if alpha is equal to 2%, alpha is the significance level. One tail. Okay, so what's this area here going to be, guys? 48%, right? Guys, if you go, do me a favor. Go to your formula sheet. This formula here. Look here, everyone, please. Okay, I want you to add to that formula. Okay, on this bottom left, add in mu of x. Okay, because that's what I use for this. I've got a confidence interval question, right? For means. And they don't write the mu of x, but this formula gives us the lower boundary and the upper boundary of the confidence interval, right? The one to the right of that, add in p, okay, and add in on the formula, put on every p in the formula sheet, add in a hat. One to the right of that, this one with the p's. Add in the letter p, because it's giving you the upper and the lower boundary for the population proportion confidence interval, and add in hats onto everything in the formula sheet. That's the way it is, right? Okay. Okay. And this formula over here, z is equal to x bar minus mu over sigma root n. Okay. That is the formula that we're generally going to use for hypothesis testing. Okay, so that formula is, and the formula sheet is for hypothesis testing, as is that complicated one we've just written down. Sorry, what you hit. Okay. All right, so an area of 0.48, what does that give you as a z-score? 2.05. Okay, so now, okay, I do my test, okay, using this formula over here. If my z test score ends up to the right of 2.05, what does that mean? It means there's sufficient evidence to reject the null hypothesis. If it doesn't, there's insufficient evidence. Okay, so first I get the z-score for that particular significance level. Okay, now I'm going to do the test score for the actual survey that I'm looking at. So you're going to plug these numbers in. But remember, mu x minus mu y is 0. A lot of people think they panic. They're like, oh, what's mu x? What's mu y? Okay. It's 0 in this case. Okay. Right, so go put your numbers in here and go get the Z test score. Okay. So this is for this over here is for the significant, this 2.05, okay, is that always has, this is for my critical Z score. That's got to do, but now that's for a 2% test. Any 2% test, no matter what the survey is, that's your Z critical Z score, right? Now I'm going to look at my specific test over here with the information I've got, and I'm going to find the Z score for that. Okay, and I'm going to see, does it pass 2.05? Okay, so I'm going to use this formula over here. I'm going to get Z. What's X bar? X bar is 30.06. Minus Y bar is 29.84. Sigma X, they've actually given you sigma X squared, okay, is 0, you don't have to even square it. If they just gave you sigma X, you'd have to square that number. 0.0784. Okay. number for X was 60 plus 0.168. And the number for Y was 50. Okay, put that into your calculator. Remember, you should get 3.22. You get that?
So I put it in like so many times. And
30.06
what did you
minus 29.84 over 0. Did you get 3.22? Yeah. Over 0.784 over 60 plus 0.1. Yeah, you should get 3.22.
Yeah.
So then I'll get 3.22.
Yes.
Okay. Right, so make your conclusion now. Okay, so what can I say, guys? My test score ends up here, right? There's 3.22. Okay. Is there sufficient evidence to reject the null hypothesis that they are equal? Yes, there is, right? Yeah, because it's falling into the significant zone, right? So your conclusion is there is sufficient evidence to reject the null hypothesis.
with the 2%? It doesn't look significant. Let's say that.
And you don't have to. Yeah. Okay. Let's start the next one. What does alpha stand for, guys? Alpha is your significance level, right? For X bar minus Y bar. Okay, so now guys, in this case, that's H1, right? Is that they're not just saying now that they're not the same. Okay, they're saying that the one is more than 1% bigger. What did they say? Sorry. It says find the set of values for which, yeah, would be greater than 0.1, which is 10%. So now they're making the claim. Okay, so no. What's the null hypothesis? That's why I write the counter down first. In the previous question, it was it bigger, right? So in other words, that mu x, so h, in the previous question, mu x was bigger than mu y, right? That was our counter hypothesis. In other words, that mu x minus mu y was bigger than 0. Based on that, you can then, that'll always be the equal equivalent. The original belief wasn't equal to 0, right? So I often do that first and then make that equal. So if this is H1, what's H0? equal to 0,1. Okay, so basically, with this type of question, when you're comparing means of two different things, I like to write my counter hypothesis first. Then my existing belief was it was equal to 0,1, right? So H0 is equal to mu x minus mu y is equal to 0,1. Okay, stay with me. I know your brains are frying. So now what's the question saying? The question is saying, I'm looking at this axis, remember now, has to do with mu x minus mu y, okay, right? Or else x bar minus xy. Okay. Okay. We're going to have z underneath. Okay. So now, okay, what we want to test is they saying to us, okay, find alpha. Okay, so alpha is an area over here. Okay. And I've got to find this critical z score, right? So to find alpha, I've got to find that critical z score. Okay, just hang on. Okay, so I've got to find the z score for this. Okay, this is quite tricky. Okay, so I've got to find the z score, the test score. Okay, and then work backwards. So now I'm going to find the test score over here. For what? Using the fact that mu x minus mu y is equal to 0,1, right? Now mu x, in the previous question, mu x minus mu y was 0. So I'm going to find the test z score over here. Once I've got the z test score, I'm going to find, so I'm going to do this first. Okay, once I've got the z test score, I'm going to find, based on that z score, I'm going to find this area over here. And once I've got that area over here, that's going to be step 2, because I'm going to get this area over here, which is alpha. Okay, so my first thing is I want the one to be bigger than the other by 0,1, right? Okay, so I'm going to use this formula over here. Everything else hasn't changed. The only thing that changed is that. Okay, so go get the z score if mu x minus mu y was equal to 0,1. In other words, it was 10% bigger. No, z test comes from this. It's for the actual survey. The critical, in this particular case, they are. Okay, I want them to be the same, yes. Okay. Because that will be the boundary. What's happening at this point? At this point, the difference between mu x and mu y is equal to 0,1. This is a z score that goes with this scenario. Okay, that's a z score when the mean is of x is bigger than y by 10%. Okay, so I've got to go find this z score over here. Anything then to the right of that, will be within the critical region, right? So go find your test score. So you should go to a score of, you should have got z is equal to 1,76, 3,9%. Okay, so you're going to go z is equal to x bar is 30,06, right? Minus y bar is 29,84. Okay. Hang on, minus mu x minus mu y is minus 0,1. This is the whole thing that's different, because that means 10% bigger. Over 0,0784 over 60. Okay, plus 0,168 over 50. And if you stick that into your calculator, you should have got a z score of 1,76, right? Okay, so this is this z score over here. So that's the z score. Okay, if they were 10% bigger, if the one was 0,1 bigger than the other, In other words, 10% bigger, right? Okay. So that's anything to the right of that, any significance level to the right of that is fine. You with me? Okay. So I've got Z is equal to 1,76. Okay. But the question said go find the significance level. Okay. So what I have to do? Well, I have to find this blue area first, based on this 1,76 value. Go to your table and look up a Z score of 1,76. And what did you get? Okay, 0,4608. But this is 0,4608. So the question said now, find the set of values for which there would be evidence at the that mu x minus mu x greater than equal to 10%. So any critical thing to the right of that is going to be useful, right? Okay. So the probability that Z is greater than 1,76 is equal to what? In other words, how do I find this area? 0,5 minus 0,4608. Which should give you 0,0392.
So if it's a set of values, how would you write your answer?
So your answer is okay, for alpha. So alpha, as I said, alpha must be greater than 3,92%. No, it doesn't really matter. I wouldn't penalize you if you said bigger than or equal to. So if you get it for a significance level bigger than 3,92%, it would mean that we're in the game. Tough question. Time. Come on, dig deep. Yeah.
So the significance level has to be greater than.
In order to say that this is more than 10%, if I tested this, at 10%, it's 1,76.
Okay,
Right.
That's
Yeah. Okay.
So does that go for all questions? Right?
Yes. Okay. It has to fall into the significance levels. Just to the left to be the other way around. You have to be more negative. Okay. I'm warning you about stats, guys. Okay. And Dr. Ridley says the same thing, and everyone's stats. Okay. I'm afraid you have to get used. At the moment, I understand that you haven't really. It is a bit early for you to be writing this text tomorrow, and that's why I wouldn't have commands. Okay. But even in 2 weeks' time, and even if you write in May, that's, and even me when I'm teaching it, and Dr. Ridley said the same thing. Stats is something, it's not like doing algebra or calculus or like trig. Okay. It's something you always feel a little bit of in your gut about. You're never going to see a sum and say, I know exactly what I'm doing, smash it. Okay. There's always going to be a little bit of uncertainty, and you've got to live with that uncertainty. Okay. It's hard. Right. The way it is. Okay. They are wordy, and that's what makes it difficult.
She's not saying numbers, but she's throwing things out.
I know. Okay, so that's hard. Okay, but it's useful. Okay, and if you're doing anything to do with finance or anything like that at varsity, or actually anything to do with science, you're going to come across stats. Okay, trust me, I've worked with a lot of first year master students. Getting 50% for stats will help you a lot compared to those who do it at all. Okay, right. Let's just do one more question. Do 5.1. That's easy.
So when is the baby's workshop?
I've sent it to you guys.
Sunday.
Yeah. Right.
So is there a date that we have to?
I actually think next year I'm not going to make the grade limits right now. I'm right in May. No, that doesn't help you. But I mean, some of you will get rid of the stats now. That'll be great. Then it's fine.
So I already know I'm running late.
That's fine. Okay, it really is fine.
I think I got
Is that the last question? It's fine. I didn't expect you to get more at this stage. Okay, but we have 2 weeks. 2 weeks of revision is a lot. Okay, you know, the test tomorrow I'm not worried about, guys. Okay, no, you don't have to worry about it.
But if I flop it and I get like -2%.
It's gonna be fine, right?
I couldn't
If it's disastrous, I'm gonna suck marks out of my stuff, right? Okay.
So you should use my average, my current average.
Let's have a look. Okay,
Use the marker.
right, first question, go.
Yeah.
So the biggest thing for me with these questions like number things, everyone's obsessed that every question is about permutations and combinations. It is not. Most of the time they're actually not about permutations and combinations. Okay. And you actually can get away with actually not even knowing about permutation. Every single permutation question can be done as a counting principle question. Okay. Right. So this question, okay, how many ways can they be arranged? When things are identical, we're not talking about permutations or combinations. Okay. So in this case over here, how many letters do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 letters. Okay. What are the same? We have 1 C, but we have 1, 2, 3 E's.
3 is.
And we have S's, 1, 2, 3. 3 S's. Okay. And this question would be the same, listen to me. If I said to you, you had 9 different identical balls, and 3 of those were green and 3 were orange, and others were different colors. When you see the word identical in these arrangement questions, think of them as being letters. Okay. So if I said, when you see the word identical objects, how can they be arranged? Think of words. Okay, think of letters. Okay. So if I said you had, so this question, how many arrangements are there? 9 factorial over 3 factorial times 3 factorial. The same question if I said you had 9 different lights, but 3 were red, there were 3 red and 3 orange, and the others were different colors. How many ways could the lights be arranged? It would be exactly the same answer if I said the lights were identical. Okay. So that answer is what? Yeah.
Being next to each other.
Yeah.
What about that like internal?
No, do that now. Okay, so what are we going to get for this answer? What is that answer? 10,080. Okay, 5.2, then we're done today. Okay, 5.2. Okay, the E's have to be next to each other. Okay, so I treat the E's as like being glued together. So I've got to have 2 of the E's next to each other. They can be anywhere you like, right? Okay, so the letters I've got left are C, A, S. Okay, I've still got one more. Okay, I've used up that E, L, and E. Okay, with those 2 E's, okay, 2 of the E's have to be next to each other, right? So I treat them as a single letter. Okay. What's the wording? Let's see. If exactly 2 of the E's are next to each other. Oof, this is a tough question. Okay, because you can't have the third one. You can't have the third one next to each other. Okay, this is why this is the last question. Okay, so you can't have 3 in a row. Okay, so yeah.
So let's say
The answer, by the way, is 5,040. The answer is 5,040.
Let's say, for instance, you had no clue what to do for a combination, well, for these things. And it's only like a 1-line thing that gets you your 7 marks, your 6 marks. So if I was absolutely clueless, what could I write to get something? Yeah, can you write anything to get like multiple marks?
Well, try to do something. So try to pretend that just 2
Like if I
together.
wrote out the
Okay,
hang on.
So
Would
surely
I
there
get
would
mark?
be 3 different interiors because
Wait.
you need to work it out for the E's and then the 2 spaces next to it to make sure it's not.
Yeah. Okay, so that would be, if they just said two E's are together and it could be three E's, then it would be, then it would be easy. It would be the number of external times number of internal arrangements. Okay? But then I think minus with three E's, I think we could do that, eh? So I'm going to try to do this. I don't know if this is going to work. Okay. So I want to end up, I cannot have three E's next to each other, right? Okay. So if I have two E's next to each other, right? The question was, it could be two or three. Okay. Two or three E's. I'm not sure if this is going to be right. Okay. But if I said to you, you could have two or three E's next to each other, right? Two or three E's next to each other, right? Okay. Then the number of arrangements would be, if I use this logic, number of external times number of internal of the group things. Okay, just give me a second. Okay, the external arrangements are, careful. How many things are you shuffling externally? 1, 2, remember that what's in the group counts as 1, right? 3, 4, 5, 6, 7, 8, right? So the number of external arrangements would be 8 factorial, but I've got to get rid of the repetition of the S's, right? I don't have to worry about the E's because they're considered to be one letter, right? So it'd be 8 factorial, okay, over 3 factorial. Okay. The number of internal arrangements is just 1. Because 2 factorial over 2 factorial. The two E's are just always going to be 2 E's because that is, if it was boys and girls, if that was a boy and that was a girl, the internal would be 2 factorial. But because they're identical, it's just one arrangement, right? Okay. So that's the number of arrangements if you could have 2 or 3 E's next to each other, right? Okay. If I minus the number of ways you could have 3 E's next to each other, then I should be left with just 2, right? My logic's right. Okay, because either if you have 2 or 3, okay, and you take away the 3, you're left with just 2. Okay, that's my thinking. Okay. So what's the number of ways you could have 3 E's next to each other? Okay, I'm going to use the same logic. Number of external times number of internal, right? So what's the number of ways I can have 3 E's next to each other? Okay, well then I would have this. Okay, what is it? C. Okay, and it would be C3E. Okay, grouped together. Okay, then I've got what? A, S, L, S, S, right? Am I right? Does that give me 11 letters? How many letters am I supposed to have? 9. 4, 5, 6, 7, 8, 9, right? Okay. What's the number of ways I could have where 3 are next to each other? Okay, so it's going to be minus external arrangements are 1, 2, 3, 4, 5, 6, 7 factorial over 3 factorial, right? Okay, minus times 1, right? So I'm going to end up with 8 factorial, okay, minus 7 factorial over 3 factorial, which is going to be 8 over 3 factorial, isn't it? No, what is it? I've done something wrong.
So the
5,808, what? 5,000?
808.
What did I ever say? 5,040. Okay, I'll look at it. Why doesn't that work? I do not want you to get too stuck on these things. They say
Sir, if you can't get it, how am I?
5, 7 factorial over 3 factorial times 6.
Right.
Hang on. Right. 7 factorial over 3 factorial. Times by 6. Yeah.
Together and then you take out the 100% certain that is not there. And you times it by 6, that's the number of places you can go.
Say that again.
So when you put the 2 E's together and you take away the third E,
Yeah.
7 factorial.
Yeah.
You put it over 3 factorial of the S.
Yeah.
You multiply that by 6, you can either find out the number of places the third E can go without being next to the double.
Nice.
Do you get that right? What's
Yeah, that's right. Okay, I'll thank you tomorrow. Well, it's night. Don't anything when I'm in. Okay. So yeah, that makes sense. So you remove the So you said, what did you say? Hang on. Okay, so it means that, so this is gone. Okay, so if the 30 is gone, okay, so you're left with 7 letters, eh? 1, 2, 3, 4, 5, 6, 7. So it's 7 factorial over 3 factorial, right? But then the number of spaces that it can occupy, okay, so that it's not next to, okay, would be there, there, couldn't be there, couldn't be there, could be there, 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 there. Oh no, he's gone. Okay. So it'd be 1, 2, 3, 4. That's gone. Yeah.
I think I didn't know. How did you get that?
Okay.
Because there are only 6 positions at the other equals. Yeah, I get it. So you have to multiply by 6.
So you can't use a sneaky memo inside the test.
I got my tomorrow. Wait. All right, yeah, physics tomorrow.
Physics today, AP tomorrow, and then our AP final, physics the next day.
Moving that. I've moved that. No, she had. I'm gonna send you more details to you, sir. Move to the France, move to the, I think it's, move to the Thursday. Matt, move to the following. Bye.